Hello friends, welcome to my channel Tech Buzz with Pradeep. I hope you are doing great. Today I am with you guys with new topic top 10 Transformers interview questions and answers. So this is a very important topic. Guys, without wasting time we will start from our first question. What is attention and its use? To understand the Transformers architecture, we need to understand two terminology very well. First is the attention, and the second one is the self attention. So, self attention is the subset of the attention, we can say. So, attention allows a transformer model to attend to different part of the another sequences. To actually, here we can see, if you guys are aware about the encoder and decoder architecture, then here is the encoder, decoder. So, encoder is the downsampling processes and decoder is the upsampling process. So what happens actually inside into the encoder, whatever the last hidden state we used to process that last hidden state as an input to the decoder. And in between, it is compressed to a vector, fixed length vector. And due to this strategy, the information loss may happen. To avoid such kind of the loss of the information, attention mechanism comes into the picture inside into transformer. So the attention model enables the decoder to attend to the whole sequence and thus use the context of the entire sequence during the decoding step. This is one of the feature. So actually what it is doing, it allows the transformer model to attend to the different part of the another sequence. And in this way, it is able to create a best output. So this is the attention inside into the transfer model. As we discussed in the last slides about the name of the self-attention, it allows transformer model to attend the different part of the same input sequence. So guys, here's the difference. Attention allows transformer model to attend to the different part of the another sequence. But self-attention allows transformer model to attend to the different part of the same input sequence. So both of these mechanisms are used inside into the transformers. So self-attention and the attention both are used in encoder and decoder part of the transformer. So actually self-attentions and feed-forwards are used in both encoder and decoder, but attention is used inside into a decoder part. And what it does, it attends to the different part of the another sequences to create a best prediction. So here the answer is it is an attention mechanism relating different positions of the single sequences in order to compute a representation of the sequence. Self-attention allows the model to look at the other words in the input sequence to get a better understanding of the certain words in the sequence. That is what we discussed. And the another line is a very short answer you can provide to the interviewer, like the self attention is the ability of the model to attend a different part of the input sequence when making predictions. It may be the efficient answer and short answer, but if you want to explain a little bit more detail, then these are the 4 lines you can use to answer. Coming to the next question, what are the transformers? So guys, now we understand the attention and self-attention. Then it is easier to understand what are the transformers. So transformers are the type of the deep learning model used for natural language processing and computer vision tasks. They utilize a mechanism called self-attention to process sequential input data. Transformer can process the entire input data at once, capturing the context and relevance. And friends, unlike RNN, if you are aware about the RNN, recurrent neural network, so it is the vanilla neural network architecture, and unlike RNN, transformer processes the entire data input at once, because the RNN was the sequence to sequence, but transformer processes the entire data input at once. So how this entire data can be processed at once, and what are the significance of these things? So it can be done through the attention mechanism. So the attention mechanism allows the model to focus on the most relevant part of the input for each output. So attention can deal with the fixed length text string, and the text has to be split into certain number of segments before sending it into the system as input. This chunking of the text causes context fragmentation. So these things are also very much important when we are trying to understand the transformers. So there are some drawbacks of the transformers as well. So if we send the input sequences into fragmentation, so there is a chance of loss of data. Okay. So when we talk about the features of the transformer, we need to understand actually what are the drawbacks of the transformers. But transformers gives a lot of capability to create very different models like text to image, image to image, image to video. Okay, so coming to the next question now. What is transformer architecture? Friends, we already discussed about encoder decoder block of the transformer earlier. The encoder block turns the sequence of the input words into the vector, and decoder converts a vector into the sequence. So this is the first thing. This is the main thing happens inside into a transformer model. But we need to understand actually what are the different layers inside into the encoder architecture, and what are the different layers inside into the decoder architecture. Inside into encoder, we are having the self-attention and feed-forward. These are 2 layers. The encoder inputs first pass by the self-attention layer, and then the outputs of the self-attention layer are fed to a feed-forward neural network. So once you will see inside your decoder architecture, these layers are already present: self, attention, and feed forward. So inside into the encoder and decoder, these 2 layers are common. But inside into a decoder, one extra layer is encoder decoder attention. And this is the main important part of the architecture. So what it does actually, Attentions allow the transformer models to attend a different part of the another sequence. In this way, it can do the analysis better and can do the great predictions. So in this way, we can understand the transformer architecture is the encoder-decoder architecture where self-attention and feed-forward are present into the encoder part. So what actually self-attention and feed-forward does? The encoder input first passes by the self-attention layer and then the output of the self-attention layer are fed to the feed-forward neural network. And this thing happens in both encoder and decoder. But into the decoder, we are having one extra layer, that is the attention layer. So, and this attention layer are the real hero inside into the decoder architecture that is having the capability to attend to the different part of the another sequence informations and capable of doing the wonderful predictions. Okay, guys, then moving to the next question. What is Hugging Face Transformers? So, Hugging Face Transformer is an open source framework for deep learning created by Hugging Face. I will show you guys the site of the Hugging Face where you can see so many pre-trained models over there and you can download and you can use for your project. So what it provides? It provides the API and tools to download state-of-the-art pre-trained models. Guys, there are so many pre-trained models there, and you can download them and use for your use cases and the projects, or either you can use for the transfer learning. So you can just download the model, you can train that particular model further, and you can also tune them to maximize the performance. So in this way, once these pre-trained models are available inside the Hugging Face framework, then the importance of the vanilla RNN and CNN is decreasing. And nowadays in the industry, transformers models are a lot used. And new variants of the transformer models are developed every day. The team at the Hugging Face has democratized the use of the such state-of-the-art model with the help of the Transformers API. You can use the Transformers pipeline and you can download all those pre-trained models for your use. Friends, I would like to show you the Hugging Face URL. This is the huggingface.co. This is the URL, and here you can see there are multiple pre-trained models are uploaded. Inside the multi-models, we are having the multiple trained model, text to image, text to video, image to text. Similarly, for the inside the computer vision, we can see some of the models: image classification, image segmentation, image to image. In natural language processing, we are having some of the models like translation, summarization, text generation. In audio, we are having text to speech, audio classifications. Similarly, we are having further reinforcement learning, robotics, tabular regression. So I would like to show you one example demo for text to image, and we are choosing this model. Suppose I am going to provide the input as a cat, then it should generate the image of the cat. Wonderful, guys. So here you can see it generated an image of a cat. Okay, so to, to the slides and coming to the next question. So, what are the pipelines? So, pipeline functions allows you to easily download any pre-trained model and perform any NLP task in just 2 lines of the code. I showed you guys about the Hugging Face where we have seen so many uploaded pre-trained model and how we can use that pre-trained model, how we can download and use for our project. So for that we need to understand a pipeline. So pipeline functions allows you to easily download any pre-trained model and you can perform the task. These pipelines are offering a simple API dedicated to several tasks, including named entity recognition, NER, masked language model, sentiment analysis, feature extraction, and question answering. So these kind of the models are also uploaded inside to the Hugging Face and we can use. Few of the pipelines are as below: audio classification pipeline, conversational pipeline, image classification pipeline, question answer pipeline, summarization pipeline, text generation pipeline, object detection pipeline, and many more. So you can use any of these pipeline model and you can use for your project purposes. Here I will show you a small demo for sentiment analysis. So for that I will just use the Jupyter notebook to show you. So first of all, we need to understand actually what we are doing. We are doing the sentimental analysis on this text input text, and it is giving us the score of negative and positive sentimentation. So here it is showing 98%, 98.39, and here 99.98%. So they are the very good result uh, predicted by the sentimental analysis pipeline. So I will show you guys how we can just run it and use it. It's a small demo. So here we have just downloaded the transformer very first. After successful uh, installation of the transformers, we have installed the TensorFlow because that is also required. And finally, we have imported the pipeline from transformers. What kind of the pipeline? This is the sentimental analysis pipeline. This is the classifier. And we are providing the input like, I don't like this movie. My school is helping me learn new and wonderful things. So I will run this. See, outstanding. So this is the results what we are achieving. So the label as a negative 98.390 and label as positive sentimentation, this is 99.98%. So here we have just used the sentimental analysis checkpoint. We can use some other pipelines we have stored into the slide like 7 to 8 different pipelines for different purposes we can use. We can also generate text over here with some of the inputs and we can do the translations, we can do the summarizations. So Transformers API very much powerful and we can use for different purposes into our project without bothering with vanilla CNN RNN. Okay, so The next one is what is tokenization. So tokenization is one of the first steps in an NLP pipeline. Tokenization splits the raw text into the small chunks of the words or sentences called tokens. If the text is split into the words, then it is called as word tokenization. And if it is split into the sentences, then it, it is called as sentence tokenization. We have to choose the appropriate method as per the task in the hand. So guys, actually, once we run the pipeline now, so first task is to convert into the token. First tokenization happens. Okay. Next question is what is auto tokenizer from pre-trained method? So in the previous slides, as we discussed, pipeline uses the tokenizer function first to convert the raw text into the numerical representation. However, each model uses a different tokenization techniques, right? Because all all of the models will not use the same technique, right? This is where the auto tokenizer from pre-trained methods comes into the picture. It automatically identifies the relevant tokenization technique pertaining to the specified model using the checkpoint name of the model. By, by identifying the name of the checkpoint model, it can automatically identify the relevant tokenization technique. So this is very much useful because it is automatically identifying what kind of the tokenizer we have to use for that particular model on which we are going to work through the pipeline. It is also very much asked inside into the interview discussion. Okay. The next one, what is the BERT, bidirectional encoder representations from transformers? So BERT is an open source machine learning framework for natural language processing, which was pre-trained using text from Wikipedia and can be fine-tuned with question and answers datasets. So this model is basically pre-trained on Wikipedia, and it is capable of giving you the answer whatever we find inside into the Wikipedia. So this is the specialized model which is trained on the Wikipedia. Okay. So but is different. It is different. How it is different actually from the others? Because it is designed to read the sequence in both directions at once. That is the great feature of the BERT. In this BERT model, it is designed to read the sequence in both directions at once. This is the great feature of the BERT. And that is why it is known as bidirectional encoder representation from transformers. Okay. Coming to the next questions, what are the limitations of the transformers? So in the last few slides, you have seen what are the importance of the transformers, what is Hugging Face, and we can use all of those pre-trained models for the transform learning inside into our projects. And these transformers models are always being uploaded inside into the Hugging Face for our uses, industry uses. These are the industry ready models, and it is highly used inside into the industry because they are a ready-made solution. But friends, whenever we are having the importance of any of the technology, then there should be a limitation associated with that. So here we will discuss about the limitations. In the other slides, I have also just took the name of about the limitations. So we discussed like transformers has a huge improvement over the RNN based sequence to sequence model, right? But unlike RNN, transformers processes the entire data input at once. The attention mechanism allows the model to focus on the most relevant part of the input for each output, right? But the drawback of transformer is that it is having the attention model inside into the decoder that can only deal with the fixed text length of the strings. And text has to be splitted into a certain number of segments before sending it into the input system. This chunking of text causes context fragmentation. If sentence is split from middle, then a significant amount of context is lost. So one of the benefits of the attention is it can try to find the relevant part of the input for each output. But it is also good. If the input is very large, then we have to fragment it because attention mechanism can only deal with fixed length text strings. This is the limitation. And due to this limitation, we have to fragment. We have to fragment the input text and then we can send it into the input system. And this chunk of the text causes context fragmentation. And this is the drawback of the transformers. Okay, thank you guys. I hope you liked this video. And if you have liked this video, please like it, subscribe my channel. Have a great day. Bye.